So, we will continue our study about the constituent of an atom. So, we have seen the what we have learned. So, we have seen about the discovery of electron and proton, and this the charge and mass of electron from J. Thomson's experiment as well as Millikan's Oil-Rough experiment, that we have seen that charge of electron is 1.6 negative of course into 10 to the power minus 19 coulomb, and mass is 9.1 into 10 to the power minus 31 kg kilogram. Okay. So, that was about the electron, and then we have seen the discovery of proton by Rutherford from his famous gold foil experiment. So, basically proton is a heavy mass particle concentrated in a small volume compared to the size or volume of the atom. So, it is positively charged equal to the charge of electron. So, it has positive charge equal to the electron charge, but it is very heavier than the electron, and all mass is concentrated in a small area or region in the atom. So, size of the atom and size of this that is basically nucleus, this I think it is 1/10,000th of the size of the atom. So, I think this size of the atom, if it is around 10 to the power minus 10 meter, then the size of the nucleus where proton is concentrated, so this around 10 to the power minus 14 meter. So, the difference is 10 to the power 4 order of magnitude. So, now we will see the discovery of Newton. So, various experiments showed that the mass of nucleus is apparently twice than the number of proton in nucleus. So, what is the origin of this additional mass? That was the question, and Rutherford postulated the existence of some neutral particle having mass similar to the proton, but there was no direct experimental evidence of these postulates. So, then in 1930, W. Bothe and H. Baker, they found an electrically neutral radiation when they bombarded beryllium plate or window with alpha particle. Okay. So, that means this they took a source of alpha particle, say this is the source of alpha particle, so this is a source of alpha particle. So, alpha particle is emitted from the source, and they put a foil and this alpha particle bombarded this foil. So, this they took the beryllium foil, they took also this lithium foil, boron foil. So, this basically light element, foil of light element. So, this when it alpha particle bombarded on this, then Bothe and Baker they found that an electrically neutral radiation is emitted from this foil. So, okay. So, that and they thought that this radiation, neutral radiation is nothing but a photon with high energy. Okay. So, they thought they are photon. So, this photon, this light is neutral. Okay. So, it is neutral, it was confirmed, and they thought it is photon, but we will see actually it is not photon. So, then in 1932 this Irene and Frederick Joliot Curie they showed that if this radiation hits another screen or another film, okay, of paraffin, or this hydrogen contained any other substance. Okay. So, then they found Irene and Curie, they found that from here this from here this some particles are emitted. Some particles are emitted from there. Okay. And these particles are basically proton. These particles are basically proton. So, that was the observation of Irene and Curie. So, now question then in that so in 1932 Irene and this Curie they did experiment, they extended the experiment of the Bothe and Baker, and they didn't think about this radiation which is coming out from the beryllium. They thought, okay, this is photon. Now this photon again bombard these paraffins, and then from paraffin these protons are coming out. Okay, protons are coming out. So, some protons are coming out. Okay. So, now question arises that there are a lot of discussion on this experiment, and question arises that this, if it is photons, is very light, right? It's massless, and now it hits this foil of paraffin and from there these particles are coming out, protons are coming out, which mass is very heavy. Okay. It is I think 1836 times heavier than the proton, is 1836 times heavier than electron. So, this how photon can eject this heavier particle from paraffin. It's impossible. So, then in 1932 itself, the James Chadwick, he performed the experiment, the same experiment, taking different this target. Besides this paraffin, some other target also he used, and he analyzed the change of energies of this target, and he found that this is not a photon, it is neutral, but it is particle. It is not a photon, it is neutral, but it is particle. It is particle. Okay. So, this particle, he analyzed this particle and he found this particle as a neutral, and its mass is similar to the mass of proton. Okay. So, these are a new particle, and he gave the name of this particle is neutron. Okay. So, thus this another particle, another constituent of atom is discovered, that is neutron. Okay. So, now we know this overall constituents of an atom, that is basically electron, proton and neutron. So, you can see how long time was taken to discover these constituents of an atom, right. So, it is still up to 1930 it was not known about the neutron. Okay. So, it is nice. So, now we know, or it is clear to us that in atom electrons are there, protons are there and neutrons are there, and protons and neutrons, they are in nucleus, they are heavier particle, and they are concentrated in a very small region in the atom, that is called nucleus. So, we have nucleus and this atom where electrons are there. Anyway, so that was about the constituent of atoms. Now, we will see the historical background of structure of an atom. Structure of an atom means this how these particles are arranged in an atom. So, that also long history, it took long time to understand as this time taken for the discovery of the constituents of an atom. So, here just for determining the structure of an atom, this light spectra, that was very helpful. Helpful means without that analysis of light spectra or without understanding the light spectra, it was not possible to understand the structure of the atom, right. So, structure of the atom means how the constituents are arranged in the atom. So, as I told, these light spectra have contribution, major contribution to, or only contribution to understand the structure of atoms. So, let us survey the light spectra. So, it is also long history, as I mentioned, that in 1666 Newton discovered that sunlight, when allowed to pass through prism, was decomposed into a beautiful band of color called spectrum. Okay. So, when sunlight was allowed to pass through a prism, then spectrum, that color spectrum or band, color band was observed. Now, before Newton, basically that was observed, whenever the sunlight passes through a clear crystal, and then this color band was observed, but that was explained that it was thought that this color band was generated by the crystal. But first Newton, he explained that this light itself is composed of many colors. Okay. It is, this color is not generated by the prism or crystal. So, that was the right explanation basically. Later on we found that, now we know. So, but that time Newton first he predicted, he mentioned that light is composed of many colors. Okay. So, after that, more than 100 years later, Fraunhofer discovered the dark absorption lines of the sunlight spectrum. Means sunlight, generally earlier the spectrometer, there was it was strong measurement, this science was this field was very strong in spectroscopy. So, without understanding but analyzing the different kind of spectrum, that was going on. And so another observation by Fraunhofer. What was that observation? This, you have spectra, sunlight, spectra of sunlight. So, there are some spectral lines, but some lines are missing, or black lines, some lines are missing. Okay. Very few, but some lines are missing. So, that is called dark absorption lines. Okay. So, why it happens? In spectra, bright lines are there, okay, that is fine. Now, some lines are missing, some lines are absorbed. So, why it happens? So, that next Foucault showed that when light from a source, basically from a powerful arc means this, if you take two electrodes, so positive and negative power is given. So, if you take them very close, so air gap will be there, means there will be high resistance, and then the spark, you have seen sparking, right, we tell sparking. So, light comes out. Okay. So, that is this is called arc. Okay. So, from this arc, it's basically we get very bright light from this arc. So, Foucault, when he passes this very bright light through the sodium vapor or sodium gas, okay, flame. So, then after that he analyzed the spectra and he found that two lines are missing. Two lines are missing, that is called D lines. Probably you know, or if you do not know, I will teach it later on. So, sodium light is called D lines, okay, D1, D2 lines. So, two lines, these very bright lines, very famous lines from sodium source. So, these two lines are missing, D lines are missing. Okay. So, original light from arc. So, if you just directly see the spectra, whatever the lines are there. Okay. Now, if you before taking spectra, if you pass through the sodium vapor, then it is seen that the two lines are missing. So, two black lines are observed. Okay. So, why it happens? So, that was the discussion, big discussion. So, what is the origin of these black lines? So, this immediately Kirchhoff, he came up with theory. He came up with theory that sun is surrounded by layers of gas acting as absorbing skin. Okay, because as observation was that this sunlight, that spectra, sunlight spectra have the absorption lines. Okay, and Foucault, that he showed that when light passing through a medium, passing through gas or vapor, say sodium in this case, then these corresponding lines are missing. D1, D2, which is the basically source of comes from the source of sodium, that two lines are missing. Okay. So, we can say that this light from arc, so it was having this all spectral lines. Now, when passing through the sodium vapor, so that two lines are absorbed by the sodium. Okay. So, it has, so matter has absorbing power, it has emitting power, so also it has absorbing power. So, that was assumed by the Kirchhoff, and he immediately came up with the theory that, so from sun whatever light is coming, it has absorption lines, means some gases are there surrounding the sun, and that gas absorb that corresponding lines, and that is the origin of the black lines, of the absorbing black lines. Okay. So, that way things was developed, and then also Kirchhoff gave experimental proof that was in 1859, the ratio between the power of emission and the power of absorption for light of the same wavelength is constant for all bodies at the same temperature. Means if you take any bodies, if you keep them at same temperature. Okay. So, now for a particular light, for a particular wavelength, okay, the absorbing power of any substance out of them, the ratio of absorbing power, ratio of the emission power and the absorption power, that is always constant. Okay. So, from here you can see that absorption or emission of light, so it depends on the substance and it depends on the temperature. Okay. So, and also one can tell that for a particular substance, if its emission power is high for a particular wavelength, So, its absorption power will also be high for the same wavelength. Okay. So, this type of corollary you can draw from this experimental result. So, basically it tells about the relation between the light and matter, they are related. Okay. So, next in 19th century it was found that spectra of many elements contain hundred of lines, many lines, whereas there are some elements which contain only very few lines. Okay. So, in hydrogen spectra, few lines apparently comprised its entire spectrum. So, hydrogen for hydrogen its spectrum contain very few lines. Okay. But there are some and other elements also there which have few elements, but there are many elements which have which contain the spectrum of that elements contain many lines. Okay. So, whether spectra is basically is light wavelength, it depends on the wavelength of light. Okay. So, basically it is light and it is related with the elements substance. Okay. So, the spectra basically substance dependent, right, matter dependent. So, matter contains the atom, right, matter is made of atom, right, and now the light, spectral light is basically is related with the matter, related with the substance, that means it is related with the atoms. Okay. So, hydrogen spectra was known in 19th century and the spectrum was like this. Okay. And so, this call is then continuous basically. So, it generally tells H alpha line, H beta line, H gamma line and I think this H delta line. Okay. So, these are very prominent lines. Its wavelength I can write, I think this is 6563 angstrom. So, this is having 4861 angstrom. Okay. So, this similar way it has this wavelength also measured and now, but it was unknown that how these lines are coming. So, it is coming from hydrogen, it is coming from hydrogen gas, so that time it was not known probably about the concept of atom anyway. So, but it was difficult to understand what is the source of these lines, but in 1885 I think 1885 Balmer gave an empirical formula. That formula was like this: nu bar equal to R 1 by N1 square minus N2 square. Okay. So, if you take N1 equal to 2 and N2 equal to 3, 4, 5, 6 etc., then for a particular value of this R and that value to fit with this value, this to get this wavelength, okay, this nu bar is basically 1 by lambda, it is called wave number, So, it was found that this if R is 1 0, I think I have to write exactly, yeah, 1 0 9677 58 centimeter inverse. Okay. If this value is taken, then and n 1 equal to 2, and if you take n 2 equal to 3, so exactly this wavelength is this line is get, then n equal to 4 this, n equal to 5 this, 6 this, etc. Okay. And for n equal to infinity, you get this limit, series limit. Okay. So, that was the empirical formula. There is no basis, because in 1885 nothing was known about the atom, right. Even I think yeah. So, discovery of electron, proton, neutron, this only after yeah, in 1897 only electron, 1911 this proton, and 1932 this neutron. Okay. So, anyway, this was nice empirical formula. So, it can fit, it can give this data. So, but this R has to be this constant. Okay. So, this way later it was found that, of course, Balmer's formula was related with the structure of atom, that we will learn, So, I will stop here, I will continue in next class. Thank you.